Assalamu alaikum student. I am Ahmed Shah. Today we have to discuss about the electrochemistry. In the part 1, we have discussed the introduction, definition, types of electrolytes, and the process of electrolysis as well. Along with these topics, one more topic has been discussed, which is preferential discharge. Now we have to discuss it again. What is preferential discharge means? We have a list of cations, positively charged ions, and the anions, negatively charged ions. These cations from cesium to platinum, reactivity decreasing. Reactivity stands for the release or lose of electron ability decreasing. If losing of electron ability decreasing, so it means absorbing of electron ability should be increased. It means that if a solution contains two different types of ion, one is hydrogen, which is present in water, because all ionic compounds which are soluble in water, when they dissolve in water, they produce their ions, positive and negative ions. So water also discharge or dissociated into H positive and OH negative ions. If we have two different ions in the solution, like H positive as well as calcium or magnesium, aluminum, zinc, chromium, iron, which ions which are above the reactivity series, in the reactivity series above the hydrogen, suppose we have two different types of ions in the solution. For example, we have hydrogen ions in the solution as well as magnesium ion or calcium ion or any positive ion here. So both are positive. So because magnesium is a highly reactive metal, all metals which are above the hydrogen in the reactivity series, they can lose their electron. So acceptance of electron is very difficult for these ions. So magnesium ions cannot be discharged, but hydrogen should travel at cathode. So decreasing reactivity means absorption of electron is easy from top to bottom, and the release of electron ability decreasing from top to bottom. This is called reactivity series. So if another solution contains H positive ion in the solution, along with the copper ions in the solution, copper is also positive nature, but it is found below the hydrogen. So at this time, copper ions must be discharged at the cathode, hydrogen does not. This is called decreasing reactivity. The upper ions cannot be discharged in presence of hydrogen. Hydrogen should be discharged at cathode in the form of hydrogen gas. If solution contain hydrogen ions and those ions which are found below the reactivity series, below the hydrogen, then these ions must travel towards the cathode. They accept the electron from the cathode, reduction take place, but hydrogen cannot produce as gas. So copper ion, mercury ion, silver ion, gold ion, platinum ion, they must be discharged in presence of hydrogen ion. For your reminder, hydrogen ion have a middle order position above the reactivity and below the reactivity. Some metals are there. So if we have two different types of ions in the solution, hydrogen ions, and one of them which are above the reactivity, lead, stannous, nickel, iron, chromium, zinc, aluminum, magnesium, calcium, sodium, potassium, or cesium. So because these ions cannot be discharged in presence of hydrogen, but hydrogen should be discharged as gas at cathode. This is called reactivity or preferential discharge. This technique, this topic is known as preferential discharge, preference. Similarly, if we have two different types of negative ions in the solution, hydroxide, iodide, bromide, chloride, nitrate, sulfate, keep this thing in your mind. Sulfate and nitrate cannot be discharged at anode at all. Never be discharged. Even solutions are in molten, solution are is aqueous concentrated or aqueous dilute. Nitrate, sulfate cannot be discharged because they are found above the reactivity series. So, remaining components are chloride, bromide, iodide, and hydroxide. Chloride, bromide, iodide are generally known as halide ion and hydroxide ion. If we have two different ions in the solution, OH negative ions after dissociation of water in the solution, as well as chloride ion or bromide ion or iodide ion. One of them, which is negatively charged. If chloride ion are more in concentration than water, it means concentrated solution is here. So beta, chloride ion or bromide or iodide must be discharged as gas at anode. But solution is dilute. If solution is dilute, contain OH negative ions along with the chloride ions, but now chloride ions are less in number due to dilute solution. So they have less number of ions in the solution than OH ion. At this time, hydroxide ion must be traveled towards the anode. As a result, oxygen gas is produced. So anions can be discharged preferentially, but depend upon their concentration. Without concentration, they cannot be discharged at all. So for your easiness, sulfate nitrate can be eliminated from the list because they never be discharged at anode, remaining ion chloride, bromide, iodide, and hydroxide. So sulfate, nitrate, carbonate, so carbonate are insoluble in water, so they cannot be used, these compounds, for electrolysis. So remaining compound are iodide, bromide, chloride, nitrate, or sulfate. These compound salt, they contain these types of negative. Out of them, only chloride, bromide, iodide, or hydroxide can be discharged. If you have oxide, aluminum oxide, sodium oxide in the molten condition, then the oxygen can be obtained because oxygen also discharged and present in the reactivity above oxide, above chlorine. Now, this is the technique which is called preferential discharge. Cations are always discharged in the reactivity order, means hydrogen ions is present along with the above metal ion above the hydrogen. So above metal ion cannot be discharged, but hydrogen should be discharged at cathode. And if solution contain hydrogen ion along with the below the ions reactivity, below the hydrogen in the reactivity, then these lower ion like copper, mercury, or silver, or gold, or platinum, they must be discharged. At that time, hydrogen cannot be discharged because decreasing reactivity upward to downward or increasing the ability for gaining the electron. The lower the ion can accept the electron than the upper one. This is the conclusion of preferential discharge scheme. So, anions follow this order, but in concentrated solutions, halogens are discharged first. Their oxygen cannot be discharged at all. But solution is dilute. Then oxygen can be obtained at anode by the electrolysis process of OH ion. It will be discussed later on in the same topic, inshallah. Now, we have to move. This is called preferential discharge. First, we have to discuss our molten cases. It has been discussed so many times, but for the purpose of recalling the topic, electrolysis of molten lead to bromide. Even compounds are soluble in water or insoluble in water. They can be changed into molten state, like sodium chloride molten, lead to bromide molten. Any molten compound is there for the electrolysis. So lead to bromide ion can be molten form, contain lead ions and bromide ions only. We have only two different types of ions. One is positive type and second is negative type. Lead ions move towards the cathode being positively in nature. Cathode is negative plate. While the bromide ion or chloride ion or iodide ion, they move towards the anode because they are negatively charged and anode is positive plate. At anode, oxidation takes place, loss of electron is observed, increase in oxidation number observed. So bromide ion lose the electron, oxidation, and are neutralized to atoms of bromine. And then bromine atom combined together, they produce bromine molecule. So beta, before reaction, bromine charge is -1 and afterwards 0. -1 is less than 0. 0 is greater than -1. That is why the increase in oxidation number, it is the result of loss of electron, means loss of oxygen. So it is called at anode. Not loss, gain of oxygen. Because oxygen is added, then loss of electron or increase in oxidation number observed during this reaction. Brown color fumes of bromine gas are seen at the anode. If chlorine gas is produced, greenish yellow fumes of chlorine gas will be seen. Similarly, if iodide ion is there, the iodine vapors of color or purple color can be obtained, can be discharged. What happened at the cathode? Lead ions are positively charged, so they travel towards the cathode because cathode is negatively charged and lead ions are positively charged. So they travel towards the cathode where reduction, gain of electron or decrease in oxidation number is observed. 2 plus is greater than the 0. So with the charge number, oxidation number is decreasing. That is why at cathode, always positive ion, they must travel towards there. They gain electron and they change their species from positive to neutral. So electrolysis is the chemical process which bring about by the electric current. Positive, negative ions change their nature into neutral one. So oxidation takes place at anode means loss of electron, increase in oxidation number, while at cathode there is reduction means gain of electron or removal of oxygen or decrease in oxidation number. During all the molten cases, all metals which are obtained at cathode, they are found in the molten form. So the molten lead, molten magnesium, molten sodium, molten aluminum, any metal which can be discharged at cathode is found in the molten state. So they can be stripped off or they can be evacuated at the bottom of the electrolytic cell. This process is known as lead bromide change into lead atoms and bromine molecules. So positive, negative ions, they just change their species from positive, negative to neutral condition. This is called overall reaction in lead to bromide component. Now, we have to discuss one more thing. Need to be discussed for the easiness of the topic for understanding. Molten cases, lithium, sodium, potassium, rubidium, cesium, magnesium, calcium, aluminum, any metal in the form of molten case, if they contain chloride, bromide, iodide, even oxide, they can be used as an electrolyte by passage of electric current and they can be converted into their respective metals and their ions into neutral form. So at cathode, these metals should be obtained in the molten cases, and appearance of all these metals is silvery white. Lithium till aluminum, lead to color of the metals in the molten state is silvery white. At anode, chloride can be discharged in the chlorine form, so yellowish green, greenish yellow gas is produced. In the form of bromine gas, it is red-brown vapors. In the form of iodine gas, this is purple color, and in the oxide is colorless, oxygen gas. Now, the first case we have been discussed, lead bromide. Now we have to take one more example for the understanding clearly of this topic here. If magnesium iodide salt is found in the molten condition, molten state, what happens? When magnesium iodide is heated, it just ionizes into magnesium ions as well as iodide ions. What happened when electric current is passed through this mixture? At cathode, which is negatively charged, it is called negative plate. So magnesium ions are positively charged, so they travel towards the cathode by electric current where they accept gain electron from cathode. So reduction takes place and molten magnesium is obtained. And the appearance of this metal is silvery white. This is called ionic equation. Takes place at cathode. Magnesium ion gains electron. As a result, molten neutral magnesium atom is formed. At anode, this is positively charged and positive plate. So with the iodide ions or chloride ions or bromide ions, they are negatively charged. So they travel towards the anode positive plate by electric current where they lose their electron to the anode here Oxidation means loss of electron takes place. Violet vapors of iodine, if iodine gas is produced, the violet color vapors are here. If chlorine gas is produced, greenish yellow vapors are there. If bromide change into bromine gas, then the reddish brown vapors of bromine gas is formed. This is the ionic equation. Iodide ions lose their electron, change into iodine form I2 because we have some non-metals, they exist in our nature as diatomic molecular form. So iodide change into iodine vapors. Second condition for the molten cases, calcium chloride. Calcium chloride, when it's heated, it decomposed, it ionized, it dissociate into calcium positive and chloride negative ions. What language should be written? As the detail of the process, you know that cathode plate is negative plate, it contains negative charge, so positive charge type ions travel towards the cathode. So we just change the word magnesium to calcium. Calcium ions are positively charged, so they travel towards the cathode by electric current where they accept gains electron from cathode takes place and molten calcium is obtained. And what is the appearance of calcium? It is silvery white or white. What happened in the next part in the cell? At anode plate is positively charged, so chloride ions are negatively charged, so they travel towards the anode by electric current where they lose their electron to the anode. Here, oxidation, loss of electron, increase in oxidation number is observed. So chlorine, greenish yellow vapors of chlorine are discharged or obtained. The two chloride ions lose their electron, change into chlorine molecule. We are here in the molten calcium chloride. Same type of answer is here. The next part, molten sodium chloride. This is the last case for the today's class. We did not, we do not need, we do not need the extent of the next session today. Molten sodium chloride case, when sodium chloride is heated, similar action is taking place. Sodium ions and chloride ions are there in the molten mixture. These ions are free to move. This is called dissociation. This is called ionization. Even ionic compound dissolved in water, dissociation takes place. Ionic compound dissolved in water, dissociation takes place. Or ionic compound are heated until they melt. They also contain ions positive, negative. This process is also known as ionization or dissociation. What happened when electric current is passed through this molten mixture at cathode, negative plate, these sodium positive ions, they travel towards the cathode where they accept electron from the cathode. Here, reduction, gain of electron takes place. As a result, silvery white molten sodium metal is obtained. This is the equation of the reaction. Two sodium ions accept two electrons. As a result, sodium molten metal is formed. While at anode, which is positive plate, anode is positively charged plate, so the opposite charge ions which are negatively charged, so chloride ions are negatively charged, so they travel towards the anode by electric current where they lose their electron to the anode. Here, oxidation, loss of electron or increase in oxidation number is observed. What is the appearance of the chlorine gas? Greenish yellow vapors of chlorine gas is obtained. Same case again, molten KBr, we just change the equation, the remaining language is same. The remaining language is same. If we decrease the size, now you can compare both the cases like sodium chloride and potassium bromide both. This is the molten sodium chloride and this is the molten potassium bromide. We just change the language of the question here, but the remaining process is same. Remaining process does not change. So this is the topic we have to complete now. They are called molten cases. In the next session, inshallah, We have to discuss the concentrated form of acid and concentrated form of salt, and then dilute solution of acids or dilute solutions of ionic compound. Now we have to finish our lecture right now. Allah Hafiz.